So I guess before we kick this off, this intimate session, how many of you are actually thinking of moving your infrastructure to a cloud of some sort? Yeah?
Yep.
All of your infrastructure or just part of it?
Parts.
Parts? Bits, yeah. What about yourself? No. Are you thinking of building your own private cloud or using somebody else's?
Yes and yes.
Yes and yes. Okay, both. Cool. So at Fusion.io, we're the makers of what we call a storage memory platform, which essentially is a combination of hardware and software. It's like a new tier of memory you can install in the servers that you have in your infrastructure today. And by doing that, we can accelerate the performance of that building block, essentially, that server component, and allow it to deal with a much higher workload than it has done previously, and so allow you to do more with less in that same infrastructure space. So we have cloud service providers who are using our technology to essentially consolidate their data centers, but support the workload of more users. And we're also used extensively by individual companies all over the place as well. So it's about getting fast performance and low response times, and it's also about cutting the cost of service, I guess is a terminology that cloud consumers and cloud providers might think about. So as everyone tries to support more and more loads in an infrastructure, let's just imagine you're looking at virtualizing your environment as you build out your own private infrastructure, your own private cloud. What happens when you do that is you get what's kind of known as the I/O blender effect. Lots of these small, seemingly insignificant workloads combine together, they consolidate and become increasingly more random. So as you consolidate more of these workloads together, what was previously a very easily manageable workload from a storage perspective all of a sudden becomes quite demanding from a random I/O profile. Traditionally, people have tried to support these sorts of infrastructures using conventional storage devices, and unfortunately they don't have the capability of supporting that workload very effectively from the point of view of cost, performance and response time perspective. And why is that? That's because of this sort of schematic here. So as you can see, there's the big gap between the growth that processing power has enjoyed and the rate at which storage devices and memory devices have kept up from a performance perspective. So in the last 20 years or so, processing power in your data center has increased following Moore's law, essentially. So it's increased by a factor of 2 million over the last 20 years. Storage devices, unfortunately hasn't really kept up with that rate of performance growth. So it's really increased in the last 20 years by a factor of around about 20 or so. So you've got this big gap between the rate at which CPUs could consume and process information and the rate at which information can be fed to them from storage devices or even from memory devices. As data becomes richer and more complex, memory's too small, it's too expensive, it's too costly from the point of view of power and cooling, and disks are far too slow. There's no way of a disk device actually cost-effectively feeding the CPU and keeping it saturated with information so your application can actually do good work for you, so you can gain the benefits of Moore's law that you've enjoyed through the increases in processing power. So when you're looking at building any sort of infrastructure, server idleness is your enemy, essentially. Most of the servers that are shipped to date are actually massively underutilized. These are Gartner figures from 2011. So 1 in 3 of the servers are using less than 20% of their CPU potential. Now that has a big impact on the costs in your data center, in your cloud infrastructure. And this is because of that gap I was showing on the previous chart, CPUs just can't be fed quick enough these days with information from storage devices. Around about early 90s, one disk was just about fast enough to actually feed the CPU of today, of that time rather. Today you need at least 600 15K RPM disks to actually feed information into a processor to keep it happy and keep it doing productive work for yourself. So this imbalance between CPU and the storage devices in your infrastructure really is a costly imbalance. And the way that people have tried to combat that traditionally is by throwing more hardware at the issue. So people throw more and more disk into their virtual environments. They throw more disk at their database servers. They throw more disk into their cloud to try and handle these random workloads that the CPUs demand. It might be that people start throwing memory at the challenge, but as I said before, memory, too expensive, too small, too hot. Or you end up throwing servers at the issue as well, so you get server sprawl as well as disk sprawl in your environment. In many situations, server sprawl as well as consuming space and power and cooling in your data center. Also, you have to pay, if you like, the tax of software licensing as well. So again, the costs very quickly ramp up from that perspective as well, because these things are all inefficient ways of trying to address the imbalance between I/O and process power. Of course, you can try optimizing your application, but not all applications can be optimized that effectively. And if you have a real intense I/O bottleneck, it's very hard to design around that without massively changing your architecture. So Fusion I/O is very simply, if you like, a drop in the server solution that allows you to address these I/O bottlenecks, improve the efficiency of the servers you've already got today in your private cloud or in your data center today, and actually reduce the growth of server and storage sprawl and improve the workload capabilities of that same architecture. And so redeploy equipment or just take stuff out of service when it comes to the end of its warranty life. And typically customers are looking at getting a 3 to 10x workload improvement in their infrastructure, but at the same time they're reducing the size of that infrastructure perhaps by a factor of 2 or 3. So the ROI can be compelling and very quick and very short by using our technology. So where's this problem come from? It's down to this imbalanced architecture that exists in many data centers today. So if you take a look at this diagram here, you can see that over on the right you've got some conventional centralized storage device that's holding the active and the archive data. There'll be various network components, fiber channel, iSCSI, whatever it may be, between your server and the storage that it needs to get to once it's outside of the area, the realm of RAM inside of your servers. And from the application's perspective and the CPU's perspective, the gap between app and data is huge. The CPUs of today, in the response time of a disk device, could maybe have done 1 million or so things before they actually get the information they're after. That's how so many CPUs in the infrastructure of today are idle in the way that the Gartner report described in the few slides a little bit earlier. Active and archive data kind of compete with each other as well. So you've got the random nature of active or process critical data, and you've got the long-term storage, large capacity nature of the archive data. And the two don't play too well together. That's why you also get this inefficiency growing as disks get bigger and bigger, but unfortunately no quicker. So the random nature of contention that you get when you build a cloud actually means that the CPUs are even less utilized in that cloud infrastructure. In many cases, though, you'll actually see CPUs seem quite busy, but they're still actually not doing productive work necessarily for your application. They're actually just managing the fact that they're waiting on I/O. So the application is asking again, is my data ready yet? And that's causing CPU utilization. So even in cloud infrastructures that seem to be quite well utilized, it's not necessarily giving you the return that you want towards your application or allowing you to consolidate and improve the throughput of that environment. So Fusion I/O allows you to decentralize that data and move the process critical information right next to the CPU where it can be processed very quickly. by installing it or retrieving that information once it's been stored upon one of our I/O memory devices inside the server. That puts that information microseconds away from the CPU. So the I/O memory performance profile is much more like system RAM in your server, but it's persistent, it's very reliable, and it's very high capacity. And its price capacity point is more attractive than using DRAM in the servers of today as well. So that relocation of data might be something you do manually. You might just move the very hot data that you happen to know you have in a database, for example, move the temporary areas onto the I/O memory, or relocate the entire database onto the I/O memory. Or it might be a virtual environment where you actually want to hold a hot cache of information that can be processed very quickly and very efficiently, but also still allow you to have the HA capability and the vMotion capability of the back-end storage device, which you still have on the right-hand side there as well. So I/O memory can be used in conjunction with conventional storage devices which exist in your data center today, or it can in fact in certain cases replace some of the storage that's in your data center today. Move the problem child application that's causing bad performance in your, on your data center's shared storage device, and actually just relocate it in its entirety onto some I/O memory inside of a system server, a database server, something of that nature. There's been a number of enablers that have allowed us to do this for many of our customers, and we have thousands of enterprise customers. Some customers have thousands of our devices installed in their infrastructure. Some only have perhaps one or two, where they've just literally relocated a performance requirement and run it much more efficiently off I/O memory rather than using conventional legacy storage in their data center. So flash memory, we use flash-based technology in our cards. We use a PCIe architecture, and we use an FPGA, so we're in full control over what's happening on the card as well. We don't use ASICs like you might have seen in conventional solid-state disk devices. With Fusion I/O, it's a sort of combination of our own proprietary hardware and our own software that allows us to massively improve the throughput and the capabilities of these systems, so massively reduce latency, have very good response times, increase throughput, allow us to deal with random and sequential workloads all at the same time of the same device, and essentially improve massively the throughput capabilities of the servers that you have in your infrastructure today. This allows you to design your own very cost-effective clouds using much less infrastructure and cope with peaks and troughs that you may have to otherwise massively invest up front for a cloud-based infrastructure. So I/O memory looks like memory. It's persistent. It takes the best of both worlds, essentially. So high performance like memory, but high capacity and persistent like hard disk drives that you may use in your infrastructure. The write latency is about 15 microseconds. We've got different types of card, from an entry-level capacity of 320 gig up to a card which is 2.4 terabytes in size. You can put multiple cards inside of a server if you require, and actually stripe over them using OS-level RAID techniques as well, where they're available. Fusion I/O is all about high performance and low latency, but also brings enterprise-grade reliability to the environment as well. So we're not like a solid-state disk provider or a consumer-type device. We're OEM'd by all the major server manufacturers, so HP, Dell, IBM, Supermicro, and more. And in fact, in the 4 years we've been shipping the technology, we've shipped more enterprise flash than any of our competitors put together. We've shipped over 50 petabytes to date. Essentially, one of our cards will give you the random performance equivalent to 500 to 3,000 15K RPM disks, but it will do that at 1/100th of the latency that any sort of disk device could actually cater for. And latency is really critical when you start to look at building cost-effective cloud solutions. Latency is the enemy. That's what causes the idle server and the idle CPUs that you have to pay for when you're building out that infrastructure. By using our technology, you can get much better efficiency out of those traditional server devices in your infrastructure, and so build a cloud environment that's much more cost-effective.
Question, I don't know if I...
Yeah, sure, go for it.
You've intrigued me that with the cloud infrastructure, do you perceive diskless server stations within the the cloud, where you effectively process certain kinds of data, or are you always saying this is supplemental to an actual I/O disk?
So it does sort of depend on what the requirement is of the data set. So I'd say there's really two types of data. There's the hot data or the process critical data, and there's the other data that you need to have around, but it's kind of like archive or cold information.
Yeah.
So the way to get best benefit from Fusion I/O technology is to allow us to handle the hot or process critical information. Now, for some types of data, it's very clear cut. You know exactly where that information is. You may as well just relocate it and run it off our technology rather than using conventional storage devices. For other types of technology, you might benefit from using our caching technology, which will automatically move the stuff that's become hot and service it from our cards. By doing that, it allows you to force feed the CPUs and the application information much quicker, and so get a greater workload much more cost effectively handled by doing so.
You are dealing with only software or hardware?
So we're a combination of two. So we're a hardware card device, like you see there, which can fit inside of conventional rack-based servers. We have a mezzanine form factor for HP Blade customers as well. And the card's actually driven by our software stack that gives you very low latency, very good response times, and very high, very consistent performance, but also makes it very reliable as well. So we handle all the kind of management of the flash. Essentially, you just see a block-based disk device that you can relocate bits of your data set that need to be quick onto. Or you can use our caching technology that does that whole thing transparently for you and just moves the stuff that needs to be serviced very quickly to our card and allow you to consolidate your environment while still maintaining the response times of that or even improving them. Sorry?
You can install this in the laptop?
No, we're focused purely on the enterprise side of the market. So this is stuff that you would install inside of servers in your own private cloud or your hybrid cloud, or perhaps there might be areas of your infrastructure. Let's say you're moving some of your infrastructure to the cloud, but you want to retain, say, your ERP or your CRM system on site and keep control of that because you want to have good control and good response times out of that. We get used a lot in database environments. We get used a lot in virtual desktop environments, virtual server, enterprise search. Our use cases are really broad because essentially most of the applications out there are I/O bound in some way, shape or form. So the use cases for Fusion I/O are very, very diverse.
Can I just do a follow-on? Because
Yeah,
the
sure.
other question that very much fits what you were just saying. Having done some optimization work in the past, clearly you will go up to a set of systems with a view, and often you'll prove wrong, in where the actual things are.
Yep.
Do you do a service or software to analyse systems so that you actually know whether this is beneficial or not, whether caching or using it in a different form? How would you come to the right conclusion of how much,
Yeah.
when, etc.?
So it's really around the engagement process with the technical salespeople and the sales guys within our organisation. We work closely with the OEMs as well. We're happy for customers to evaluate the technology in test environments as well to see what sort of difference it makes for them. The items themselves aren't incredibly expensive when you compare them to other enterprise ticket items. So sometimes customers will just buy a test unit and then try it out in various areas of the environment. But we do have some consistent use cases that we see. So as I said before, things like database environments and virtual desktop certainly seem to be very consistent areas that technology gets used in, but the use case is very diverse. So part of the solution is the software side of our offering, and this really is what differentiates us from all other flash-based technology that you'll see in the market today. This is how we decided to pioneer and be different and differentiate ourselves, and it's all about managing the flash, managing the performance and reliability of the device that you're going to deploy inside of your technology. So the cards themselves have the ability to self-heal or regenerate themselves. They have reserves built into the device as well. We're able to ensure that the information is spread wide across the card. We can reconstruct data if we have to, and this is all transparent. It all happens in the background as well. So from your perspective, you just see an incredibly fast device that has very, very low latency and dramatically accelerates the workload that same server can now could sustain. It is now 3x or 10x by deploying our technology. We also have the capability of hooking software applications more deeply into our technology. So we recently announced a SDK, a software development kit, which is being adopted by the software community. So we have been working with the open source community. The MySQL community is redesigning its open source database engines to take advantage of the fact that they're using I/O memory to further streamline and make more efficient their software architecture. So the abilities go much beyond just having a very fast storage device. We can actually improve the efficiencies of software when customers choose to reconstruct the way they've actually written the code in the first place. But for many people, just a quick, let's relocate the data to this new fast device gives them exactly what they need. So some examples. I've mentioned some common use cases. As I said, database is a very common one for us. So just relocate the hotspot, the pain points, move it away from conventional storage area network, a network attached storage device. Just relocate that onto the I/O memory inside of your database server. By doing that, you unlock the potential of the CPU that's driving that database server and allow it to do more transactions per second. Allow it to cater for bigger spikes in demand. Allow it to do more for less, essentially. Sometimes it'll be the entire database that gets relocated. Other times it might just be one particular part of that database. A customer might move some temporary tables, indexes, tempDB, whatever it may be, where it's I/O intensive and where it's causing a slowdown in the application as a whole. Just simply relocating that to run off the I/O memory will accelerate that same server running that same application. VDI, as I said before, is a very common use case. The thing that's really nice about using Fusion I/O for VDI or virtual desktop or buy your own desktop services, whatever you want to call them, is that you have limitless scale when you use our technology. With a virtual desktop environment, you typically have hypervisors in a farm there, and over time you'll add more and more hypervisor nodes because you need to have compute power and memory to allow these virtual desktops to operate. Conventionally, people have used shared storage, like this device on the left here. And as I said before, that's not really a great way for catering for low latency or random profile access to data. The I/O blender becomes a big bottleneck and it slows down the virtual desktop performance. Or it means you have to have a very large upfront investment in that shared storage device just to get your first few hundred or so virtual desktop users up and running and off the ground. By using Fusion I/O, we can actually much more cost effectively give you much better performance of that virtual desktop scenario. You'll still use some shared storage, but it'll be low cost shared storage. It'll just be holding things like the user shares, user profiles, those sorts of things. The heavy lifting, the I/O intensive aspect of virtual desktop gets handled by redeploying the link clones or the differencing disks from your hypervisor and running them off the I/O memory inside of the server. Every time you add more nodes to that virtual farm, you're adding I/O at the same time that you're adding memory and CPU that your virtual desktop cloud service requires. This gives you limitless scale, essentially. You can start off, you can test it, evaluate it with a single server using our technology, and you know that as you add more users, you have to add compute and memory, and you add it with another card in at the same time. So that allows it to scale in a very linear fashion. The costs are very predictable. They're very low and they're very manageable. If you rely upon a shared storage device to drive this virtual desktop environment, you have to calculate whether it will handle the load you're going to throw at it ultimately. Where is the glass ceiling? When will this environment slow down? What happens when an issue affects one node? Will it affect everyone? How do I handle boot storms? What about antivirus? All these things add up and snowball essentially and make predicting the I/O workload of your average user very difficult to cater for. With Fusion I/O, all these things still happen, but essentially we're offering you the random performance of 500 disks for every hypervisor server there, for example. So I/O goes completely out the window. It becomes irrelevant. The response times are such that essentially customers in virtual desktop environments actually get a better end-user experience than using the normal desktop they have under their desk. Outlook opens in a second. You know, the organization that deploys this cloud service actually gets benefits though, because the ROIs work out really cost effectively. They're not having to factor in a very large upfront cost for the shared storage device. They can go for a much lower cost device initially and do all the expensive I/O work cost effectively using the I/O memory. So it's a win-win all around. The ROI makes sense all of a sudden. You know you can scale, you can start small and then go to whatever sort of capacity you require in the future. And the end users love it too as well, because they get performance improvements, not slower performance and unpredictable natures when people log in and they have boot storms, that kind of stuff.
Sorry if I'm jumping forward.
No, go for it.
The trend always has been to multiple uses of that kind of technology. And if you look on the disk on your left,
yep.
That's a shared device that would formerly have been in one place, now it's a NAS. There's the obvious trend that mainframes and everything always used to do, that you actually then share the memory with multiple IOs into a single. So instead of duplicating across your 4 servers similar data, you have it in a bigger memory device. Is that a trend that you believe will happen? That instead of my plugging a device into each server, I have perhaps a bigger server or one server with a shared memory, or is that too far out?
It's interesting. Maybe that could be something that could happen. When you look at the architectures of today, though, when customers can actually drive the CPU harder and faster, the return they get is greater the simpler the technology. As you look at having non-uniform memory in complex architectures, you have to think about, well, where's the memory I'm going to talk to now? Where's the cache? Is it cached inside of the CPU of that system? Is it here or is it over there? Do I have to cross a crossbar? Do I keep, you know, a buffer closer to me so I don't have to traverse the whole way to that other cache? And so the whole environment becomes much more complex. We've seen customers actually build out cloud-based solutions at large scale using our technology, and as they've developed their offering further and made it more complex and richer, they've actually decided to go for smaller systems because they can drive them much harder.
Okay.
So
interesting.
it's in many ways doing something simple but doing it much quicker is a much more beneficial way of you actually getting the value out of your investment.
The only reason I asked the question, that moving disk will disappear at some stage on the left in some form for more solid state, in the same way that everything then comes into a central hub. The future may well be, and it's happened in the past, you actually hub that on solid state memory. And I was just interested to know whether I/O channels of a different nature were on your product.
So I think probably disk will stay around for a period of time yet, certainly, because there is always going to be this need for archive data, this cold data set. You need somewhere to store stuff forever in many cases. In fact, in some respects, you can see a future where disk becomes the new tape, essentially, and that information is held online in such a way that it can be accessed when required, but the stuff that's hot and process critical actually comes from some form of solid state device.
I'll go on with that. Yeah, thank you.
So you have product this middle part only, that hypervisor only.
Yep.
And other separate.
Yeah, so we're just sat in this layer in the middle, and as you scale that environment, this is the area you scale out. So costs at this side are really well controlled and kept small, and the performance demands that come from a virtual desktop solution are delivered by this section in the middle, and that's the area that we pump up the performance on.
Sorry if I'm jumping to slide set, but what you haven't shown us yet is a cost comparison of main memory cost per gigabyte compared to I/O memory cost per gigabyte and the performance equivalent. And surely that is what is going to moderate the choice.
So we are much more cost effective. We can help you with the
what's
yeah.
performance?
So we can help you with the
100 times cheaper, 100 times slower, or
so it's not so much the performance of the memory, because most applications need to persist their data in some state. So that tends to be the need for using some form of persistent storage device. So when you look at our technology, we give you 1,000 times the performance of disk, but we do it at a price point which is beneficial compared to memory. So our densities are such that our devices are lower cost than equivalent memory, but in many cases for many workloads, it doesn't matter how much memory you put in a server, it's still going to try and go to a persistent device because it wants to store that information. So we can serve up read workloads, write workloads, mixed workloads. Memory tends to just deal with the read workload, and disks tend to deal with the write workload. So the atomic unit, if you like, that you'll have in your data center will be a low-cost server with a, relatively speaking, large amount of our technology inside it, a reduced amount of RAM compared to what you may have tried to use previously, and a moderate amount of disk connected to it in some way, shape, or form. By using our technology, you get a benefit out of all the components within that same unit in your data center, and that workload unit can now cater for 3x or 10x the actual end user workload that's been drawn from it.
Okay, so the comparison's the other way, the cost comparison's the other way around. What's the cost comparison with enterprise storage, tier 2 storage, which I think is what you're saying you're in comparison with, rather than using tier 1 storage, use IO storage or a comparison like that?
It's much more cost effective to use our technology. It depends on what you've got. I mean, we can have a more detailed conversation offline afterwards, but essentially the ROIs for customers who have deployed our technology are incredibly short, 6 months or sometimes even instant. We've had customers who have totally transformed their data centers because it allowed them to scale. And we've had customers who are, in manufacturing and they've just bought one device just to, triple the throughput of their ERP system so they can get, their time to manufacture is massively reduced. So it's not a high-end only device that we're talking about here. It is within the grasp of everyone. So an entry-level card might be a few £1,000s. Customers can deploy several of our cards in a system, and that individual card will outperform a several £100,000 storage area network. So where you have an I/O bottleneck and you want to improve the efficiency or the consistency of an application, it's a very quick and easy way to fix that issue. Sometimes it's performance, sometimes it's cost. Customers may choose to take the same performance or handle the same workload, but they'll do it at much reduced cost using our technology as well. So we also have caching technology, which I was alluding to earlier as well. So you can use our technology in combination with existing storage that you may have in your environment. So one such solution is called IO Turbine. It's a caching solution that works with VMware, and it allows you to actually apply a totally transparent read cache to VMs in your infrastructure and accelerate the capability of their individual VMs, or increase the consolidation ratios that you see in that same infrastructure. It allows you to take the I/O bottleneck off the back-end storage device and have it served cost-effectively and very quickly from within the hypervisor system. By doing that, customers can still retain the capabilities of things like vMotion, but they get the performance benefits of using our technology. We also have a caching solution called Direct Cache, which you can use for bare metal systems. It allows you to, again, to connect our card as a totally transparent cache to any block-based back-end storage device that you have in your environment again. It works with Windows and Linux systems. You can use it with Windows clustered environments. And essentially, it allows you to take a random read workload, again, off the back-end storage device and have it served very quickly, very cost-effectively at very low latency from within that server. Again, the benefit of doing that is that you can actually accelerate the workload that that system can handle. So the same server all of a sudden becomes 3 times quicker by using our technology. Yeah. Slightly out of order there. So what's the net impact that you might see in the private cloud that you've created? Or what are the benefits that your public cloud provider could have gleaned by using I/O memory in the architecture they're reselling to you? Well, it's all about reducing the hardware footprint. Clearly, if you make an infrastructure of some sorts go 3 times quicker and use half the infrastructure, there's a benefit to be had there, as an example. Less application servers are required in that same infrastructure to support the same or a greater workload. That gives you a reduction in server footprint, power and cooling, application licensing. The costs come down. If you're using us in a virtual environment, you can have a greater number of virtual machines being hosted on the same infrastructure or a smaller infrastructure. You can virtualize the I/O intensive workloads, which previously you did not wish to virtualize because of performance concerns. If you use I/O Turbine, you can now virtualize these heavy workloads and get the return that you require by virtualizing more of your estate. Less units in your data center or somebody else's data center means less requirement for cooling and power, those sorts of things. So the whole data center itself can be consolidated, or that provider now has the opportunity to actually sell more of their upfront capex onto customers, driving down the cost of service that they're selling onto yourself for the public cloud. The storage area network, the network devices that you had in your infrastructure, by taking that random workload off those devices, you can extend the lifetime in service of those devices by using our technology as a cache for those, or even just taking off that problem application away from the SAN device and running it in its entirety off the I/O memory inside of a SQL server or an Oracle server, for example. Less servers, less infrastructure, less complexity, lower costs. If you consider some of the costs in a cloud, this is an example from an IT vendor that did a survey. And there's a lot of infrastructure costs and software costs in this pie chart here. If you could reduce by 2/3 the amount of infrastructure, as an example, that you were using, you'd be able to slash the server infrastructure costs, the software licensing costs, the power and cooling costs. Perhaps you could use a smaller facility. Perhaps it meant you didn't have to invest in a new facility for a longer period of time. Using I/O memory affects all of these components pretty much, allowing you to reduce, or allowing your supplier to reduce their cost of service for your cloud infrastructure. So we're not just about cloud. We get used in all sorts of environments, database very extensively, virtualized environments, virtual desktop environments extensively, search applications, web infrastructure. All of these have benefited from using Fusion I/O technology.
Before we go on from there, are they using a standard product in that, or are there extensions that optimize for using I/O with these applications?
So very typically, people just use our standard product in these environments in some way, shape or form. It might be our software combined with our hardware. It might just be the hardware and the standard software offering. So they're just literally relocating the I/O pain point from where it was and putting it onto our technology.
Something like Autonomy hasn't used any of the uniques that your product has to speed up more, so there's no special hooks from any of those? No,
not for Autonomy. So in the case of Autonomy, you're relocating the indexes from the IDLE servers and serving them directly off our cards. So things like acquisition or crawling or just getting response times out of Autonomy become massively accelerated. So it's a read index, it's about random reads. There's no better way of serving that up than using our technology.
That appears to serve as another drive, and you manually allocate the problem data onto that drive.
Unless you use our caching software, yes, that's what you do. So we don't use disk-based protocols, that's how we have very low latency, but our software, our virtual storage layer, essentially makes the device appear to be a block-based disk device. So you can RAID them together or carve them up, whatever you want to do. But the transfer of data between our device and memory inside of the server occurs using DMA. So it's very high performance, very high throughput. So we've got some examples here of customers who've used our technology and achieved benefits around performance. So 4x performance improvement in a data warehousing environment in a cloud infrastructure. This was like a help desk environment for a cloud provider. They massively increased their working data set and had no impact whatsoever on the performance. So with Fusion.io, it's all about doing more for less. Less cost, but higher workloads, less infrastructure, lower data center costs. There's more of these, 15 times less weight on random reads from a database. Very easily achieved. All the I/O bottlenecks in that infrastructure just disappeared by doing a simple relocation of this pain point from where it was onto our technology. So you can come talk to us at the stand and we'll talk to you about perhaps use cases that are of interest to yourself specifically. Or you can hit our website and see the case studies that might be relevant to the sort of architectures you have in mind as well. As I said, we're a young, very fast growing company, and the short period of time that we've been shipping a product, we have picked up thousands of enterprise customers, and we're OEM'd by pretty much everyone in the business now. HP, IBM, Dell, and Supermicro, to name but a few. So unless you have any more questions, I'm going to sort of bring the presentation to a close now and let you get it back.